This webcast talks about the second method that's used in the lab for Freefall. In this method, we're going to use something similar to what Galileo did. He also, like us, experienced the issue that when he tried to drop things and study how they moved as they fell, that he found that they fell too fast, and he wasn't able to really carefully observe and measure how much time it took. And we also had some problems measuring the time for the golf ball to fall in the stairwell because of human reaction time and other measurement errors. It was very difficult for us to get an accurate measurement of the time that the ball took to fall to the ground. And so we're going to use what Galileo tried. He thought, well, if instead of having them fall vertically down to the ground, what if I have them roll along an inclined plane? And so when he did that, he found that it took them a longer amount of time to roll down the plane, to the ground, and so he was able to make more careful and more precise measurements of the time that it took. And our class has really already performed similar experiments. We did a lab where we placed carts on inclined planes, and we then measured the position versus time and the acceleration of those carts rolling down the plane. And so over the years, I have collected a lot of data from Harpeth Hall teams, and I've shared that with you. If you will look on PowerSchool page 3.6, you should download this data file. It has acceleration data for different inclination angles, and it was last updated this year, 2021. Each year I add more information to that file. And by the way, you might want to view this video here on this PowerSchool page that talks about how Galileo performed his experiments. But I'm going to go ahead and talk about what to do with this file that you've just downloaded. And so when you open that, if you'll notice, it has an extension CSV. That means it's a comma delimited or comma separated file. But when you open it, it will appear in Microsoft Excel like this. And I'm just going to widen my columns a little bit so that I can see everything. Okay, so we've got the first column on the left has inclination angle measured in degrees, and it varies anywhere from 0 to like 9.2 degrees. Okay, so over the years, these are the various inclination angles that our Harpeth Hall teams have used. And then in the column B, we have the acceleration that was measured for the cart that rolled down the track that had that inclination angle. Okay, so I guess the first thing I want to do is just take a picture of this table, because it asks me to paste a copy of this table in the report here. And so I'm just going to copy this data. I've highlighted all of the data. I'm going to do Control-C, and then at step 13 in the lab report, I think I can just do a paste. And I'm going to paste it as a meta file. And just that way I don't have to worry about anything like that. But anyway, now I have this data in my report so that if anyone is reading this, they can see the same data that I have. Now it says to create a new column in this Excel table to store the calculated sine of the inclination angle. Sine is one of the trigonometric functions, and so we're just going to calculate the sine of the angle. And so first, I'm just going to put a header row here. This is going to be the sine, and I'm going to use all capitalization, sine of inclination angle. Misspelled inclination. There we go. There are no units. The sine is calculated as the ratio of two sides of a right angle triangle, and so it does not have any units. Okay, so I'm going to put a formula in here to ask Excel to calculate this. And so just please follow along with me. So since I'm asking Excel to calculate something, I start with an equal sign. And then the command that Excel recognizes for sign is just SIN, all uppercase. Then I'm going to open a parentheses, and I'm going to move my cursor over and click in the first row of the column that has the inclination angle. When I click in that row, notice that it puts the address of that cell in my formula. For me, this is column A, row 2. That's where it's going to find the value of the angle that I want it to calculate the sine of. Now, when Excel was developed, the creators decided that they assumed that angles would be expressed as radians. And in our class, we calculated the angles in degrees. Degrees and radians are just two different units that you can use to calculate or to describe an angle. But since Excel wants the angle to be in radians, I need to convert my degrees to radians. And so I'm going to do that right here. I'm going to multiply, so use an asterisk to say multiply, by pi. In Excel, the way you call the value of pi is you type pi, open and close the parentheses. Okay, so now I have my angle in degrees multiplied by pi, and then I need to divide by 180. So divide by 180, because pi radians equals 180 degrees. Okay, and then I'm just going to close my parentheses. This is the total formula that I need to use. So I'm going to hit the enter key. Okay, well, the first one is maybe not interesting because, 0 degrees is also 0 radians. But I'm going to copy this formula down the entire column of my table. The way I'm going to copy it is I bring the cursor into the lower right-hand corner of the cell that has the formula. See, here's the cell with the formula, and when I'm just out anywhere, the cursor looks like a large white plus sign. But when I bring it into that lower right corner, it changes to a smaller black plus sign. And now I'm going to double click the mouse. When I do that, it is now calculating the sine of every inclination angle in my table. Okay? So we have done this step. Okay, then the lab report says make a scatter graph of the acceleration versus the sine of the inclination angle.